So this is assignment number 31. We are continuing with lines and angles. We were doing parallel lines. In the earlier video, what I have done was I have shown you what are the different types of angles that are found in a parallel line. So in today's video, what we are going to do is we are going to use all those ideas of different types of angles in order to solve some problems based on figures. Let's take the first one. A parallel line is given to you here and we have a transversal going across it. One of the angle given is 50 degrees here. I have to find what will be x, y and z. So it is not necessary for us to find out in a serial manner, like for example x, y and z. I can go y, x and z depending on which is convenient for you. Let's begin with y. Now if you look at y, this angle is given as 50 degrees and y is vertically opposite to it. Vertically opposite angles are always equal. So if this is 50, y also has to be 50 degrees. Now why is it 50 degrees? We have to write it down. So here I can write it as vertically opposite. I'm writing it in short. I'm comparing it with 50 degrees. So I have to mention that. So y is 50 degrees now. If I compare 50 and x, from here to here, it is going to give me 180 degrees. That means they are supplement. Okay. So x will be equal to, if this is 50, this is going to be 130. 130 because it's supplement of 50 degrees. Now looking at z, I can compare z with x. If I compare z with x, they are corresponding angles and corresponding angles are always equal. On the other hand, I can also look at it z and y. Now, x and this angle here, they were co-interior angles. Y and z can be called co-exterior angles. Co-exterior angles add up to 180 degrees. So I can say that if y, which is 50 degrees here, z will be equal to 130 degrees, I can compare it with y and say that this is co-exterior angle. Very important for us to give up the reasons why these angles are of certain degrees. Let's take another example. Here I've got two parallel lines. At the same time, I've got two transversals crossing, but these transversals are not parallel. Let's go one at a time. Let's look at 110 and s. Since this is a straight line, the total of this will be 180 degrees. So I can say that s is equal to 70 degrees, that is supplement of 110 degree. I can compare 110 with x. So x will be equal to 110 degrees because it is vertically opposite to 110 degree and vertically opposite angles are equal. Now let's look at y over here. X and y, they are on the same side but outside the parallel lines, which means they are co-exterior angles. Co-exterior angles add up to 180 degrees. Therefore, y will be equal to 70 degrees Since x is 110, x and y should give me 180. So this is co-exterior to angle x. Let's look at this one here. This is 60 and this is r. This is a straight line, which means the angle from here to here 180 degrees. If this is 60, this has to be 120. So r will be equal to 120 degrees. Supplement of 60 degrees. R and T are vertically opposite angles. They are equal. So I can say I've already found out R, which is 120. So T will also be 120 degrees. That will be vertically opposite to which angle? Angle R. Now let's look at P. If you look at P, these two are parallel lines and this is the transversal. If I compare P and 60 degrees, they are corresponding angles and corresponding angles are equal. So I can say that P will be equal to, P was equal to, this is 60. So P will also be 60 degrees. So P is 60 degrees corresponding to 60 degrees. And the last one, Q. If you look at P and Q, they are supplementary angles, or if I compare Q with T, they are corresponding. So I can say Q will be equal to 120 degrees because T is also 120 degrees. Lastly, T is equal to, sorry, not T, Q will be equal to 120 degrees. It is corresponding to which angle? Angle Q is corresponding to T. So corresponding to T. And going to the last one now. A different type of figure. These two are, according to the question, these two are parallel lines. But then after it comes here, this cannot be parallel. So how do I find x and y? I can draw an imaginary line. Suppose, which is also parallel to these two lines. Let's say this is also parallel. Now what happens is, this x here has been divided into two angles over here. Let's consider this to be A and this one here to be B. Now let's calculate A first. A will be equal to, if I look at 160 and A, these two are allied angles. Allied angles add up to 180 degrees. Therefore, A will be equal to 20 degrees. So which is allied to 160 degrees. Now if I look at B, let's calculate B. B and 130 are also allied angles. They add up to 180. So this becomes 50 degrees. That is allied to 130 degrees. Now A plus B is giving me x. So I can say that x is equal to A plus B, which is A, I got it as 20 degrees, plus B, I got it as 50 degrees. That means I get 70 degrees. Now let's look at Y and X. X plus Y, they form a circle, which means it is 360 degrees. I already found out X. So I can say over here that X plus Y is equal to 360 degrees. I already know the value of X, which is 70, plus Y will give me 360 degrees. So we can say that Y will be equal to 360 degrees minus 70 degrees. So Y will be equal to 290 degrees.